Welcome, curious minds. Today, or whenever you're listening, we are diving into one of the oldest questions in human history. Are we truly alone?
It's a huge question, isn't it? Gazing up at the stars for centuries, wondering. And yeah, it touches philosophy just as much as science.
Absolutely. So today, for this deep dive, we're really focusing on the scientific side, based on our sources. What are the odds? How are we searching? What are the debates?
Exactly. We'll explore the likelihood, the search methods, and some of the really fascinating discussions happening right now.
Okay, let's start with the scale,
Yeah.
because the universe is just, well, it's ridiculously big. One source mentions 10 to the power of 26 times larger than us.
Mind-boggling, truly. One with 26 zeros, and it's been around for about 13.8 billion years since the Big Bang. Trying to comprehend that is tough.
It really is like an ant in a giant city, maybe. You can see your street, but the whole city.
That's a good analogy.
Mhm.
And within all that vastness, the laws of physics seem to be the same everywhere. That's crucial. Gravity works the same way, electromagnetism,
Unlike, say, human laws that change border to border.
precisely. This uniformity allows us to even speculate about life elsewhere. And our sources note this remarkable wealth of phenomena out there, far beyond what we see on Earth.
And this blew my mind. One source talks about a habitable epoch really early on, like 10 to 17 million years after the Big Bang.
Yeah, it's a fascinating idea. The background radiation of the universe itself might have been warm enough for liquid water to exist on, well, any rocky surfaces that might have formed by then.
So potentially, life could have started incredibly early, way before Earth even existed.
It's a possibility, assuming planets form that quickly, which is still debated. But it definitely makes you think about the likelihood of life, doesn't it?
It does. Which brings us to the Copernican idea, the mediocrity principle. The thought that Earth isn't unique.
Exactly. If the ingredients and the laws are universal, why would life only happen here? Statistically, you'd expect it to be more common.
People often bring up the Drake equation here.
Right, Frank Drake's framework. It tries to estimate how many civilizations we might be able to communicate with in our galaxy. You multiply factors like star formation rate, planets per star, fraction with life.
But it's more of a thought experiment, isn't it?
Yeah,
Because we don't know most of those numbers.
that's the key takeaway from another source, yes. It structures the problem, but the variables are largely unknown. Drake's own early guesses gave optimistic numbers, but a small change in one factor dramatically alters the result. It really highlights the unknowns.
So the main arguments for life being common boil down to: the universe is huge and old. The building blocks like carbon and water are everywhere, and the laws of physics are consistent.
Those are the big three, yeah. People like Sagan and Hawking were quite convinced by those arguments. It feels almost inevitable to some.
But then there's the counter-argument, the rare earth idea.
The rare earth hypothesis, yes. It suggests that maybe simple microbial life is common, but the specific sequence of events needed for complex, intelligent life like us is incredibly rare.
Like having a large moon for stability. Or plate tectonics.
Exactly. Things like Jupiter acting as a sort of cosmic vacuum cleaner, protecting us from too many impacts, our position in the galaxy. A whole list of things might need to align perfectly.
So if life is out there, it might mostly be simple, like bacteria.
That's a strong possibility. One source reminds us that for most of Earth's history, life was just microbes, intelligence, technology that took billions of years, and maybe some lucky breaks.
I saw that Durham University survey mentioned in the materials. Astrobiologists seem pretty optimistic.
They do generally. Something like 87% think some form of alien life exists, and over 2/3 think complex life is plausible. That's significant optimism within the field, even without proof.
And where might this life be hiding? Maybe not always on the surface.
Good point. One source suggests planets around very active stars might force life underground or underwater, shielded from radiation.
Which would make it much harder for us to find, obviously.
Definitely harder to detect remotely. And then there's the whole question of different biochemistry.
Like life based on silicon. Or using ammonia instead of water.
Those ideas are out there, briefly touched on in our sources, but water just has such unique properties as a solvent for the kind of complex chemistry we see in life. It seems particularly well suited.
Okay, so how are we actually looking? What are the methods?
Broadly, you have direct and indirect searches.
Direct means looking for the life itself, or its direct chemical signs.
Exactly. Biosignatures, chemical fingerprints, analyzing atmospheres of exoplanets, searching for certain gases that shouldn't be there without life, or looking for fossils or microbes on Mars or in the oceans of Europa or Enceladus right here in our solar system.
And the James Webb Space Telescope is a game changer for that, right?
Yeah.
Analyzing exoplanet atmospheres.
Huge potential, yes. One source mentions that tentative detection of DMS and DMDS chemicals strongly linked to life on Earth by a Cambridge team using Webb.
Tentative, though.
Very. They need more data to reach what scientists call the 5 sigma level of certainty. That's the gold standard to rule out flukes or other explanations. So exciting, but not confirmed yet.
And indirect methods.
Yeah.
That's like SETI, listening for signals.
Right. SETI, the search for extraterrestrial intelligence, mainly listens for radio waves, assuming another civilization might be broadcasting, intentionally or not.
I read the Allen Telescope Array is now focusing more on red dwarf stars.
It is. They're much more common than sun-like stars, and we now know many have planets in their habitable zones. So it's a numbers game, shifting focus a bit.
And beyond listening, there's this space archaeology idea.
Yeah, it's pretty cool. Looking for technosignatures, evidence of technology. That could be industrial pollution in an atmosphere, maybe artificial lights on a planet's dark side.
Could JWST spot city lights on Proxima b, for instance?
Potentially, yes, if they were bright enough. Or even searching for massive structures like Dyson spheres or swarms, megastructures built around stars. Purely hypothetical at this point, but we're looking.
Yeah, what about sending probes? Like breakthrough Starshot?
That's the really long-term vision. Tiny probes propelled by lasers, reaching nearby star systems within a generation. It aims to get us actual close-up pictures eventually. A huge technological challenge, but people are working on it.
We also had that strange visitor, Oumuamua. That caused a stir.
It certainly did. An interstellar object that accelerated in a way we couldn't easily explain just by gravity. Some scientists, like Avi Loeb, floated the idea of it being artificial, perhaps the light sail. Still highly debated, but it shows we need to be open to the unexpected.
Which brings us to the challenges. Fermi's paradox hangs over all this. If life is common, where is everybody?
The great silence. It's a powerful question. Loeb's perspective, mentioned in our sources, is interesting that maybe our lack of detection doesn't mean absence. Maybe we're just not looking the right way, or maybe we aren't that significant cosmically.
Or maybe we wouldn't even recognize alien technology if we saw it. The caveman and the smartphone analogy.
Exactly. Their tech might be based on physics we don't even understand yet,
Yes.
or their communication methods could be totally different from radio waves or light pulses.
Plus, space is just vast. Getting here from there, or vice versa, is incredibly difficult with current physics.
The tyranny of distance, yes. That alone could explain the silence. And then there's the debate. Should we even be trying to make contact? Is it wise to shout into the cosmic forest?
That's a heavy one. Potential risks versus rewards.
Definitely. Now, we also need to touch on the whole UFO or UAP phenomenon. Reports go way back.
Yeah, the sources list examples from ancient Rome, Tehran in 76, Rendlesham Forest, Travis Walton. Lots of history there.
And more recently, you have whistleblower testimonies, people from the Disclosure Project, even statements from astronauts like Edgar Mitchell or politicians like Obama, acknowledging things in the sky they can't explain.
Objects doing things our known aircraft can't do. Maneuvers that seem to defy physics as we understand it.
That's what many credible reports suggest. However, the counterpoint, strongly emphasized in the sources too, is the lack of concrete, verifiable physical proof. No undisputed crash craft, no alien bodies.
It's mostly eyewitness accounts, radar data, sometimes blurry videos. Hard to be definitive.
Very hard. And the sheer number of hoaxes or misidentifications over the years creates that boy who cried wolf problem. It makes it harder to investigate the genuinely puzzling cases seriously.
Though governments are acknowledging, some UAP seem to be real objects demonstrating advanced capabilities beyond ours.
They are. The debate now is largely about what they are. Advanced, secret human tech, misidentified natural phenomena, or something truly unknown, potentially non-human. We just don't have the answer.
So wrapping this section up, the scientific community needs to approach this whole subject carefully.
Absolutely. Open-mindedness is key, as our sources stress. Think about how ideas like black holes or gravitational waves were initially viewed skeptically. We need critical thinking, but also willingness to explore unusual data.
Support for research that might seem fringe but could have huge payoffs.
Exactly. And bringing different fields together, astronomers, biologists, physicists, even philosophers, is vital for tackling such a multifaceted question.
So to sum up this deep dive, the universe's scale makes life seem possible, maybe even probable in some form.
Scientists are actively searching with increasingly sophisticated tools. looking for biosignatures and technosignatures.
And while we have intriguing UAP reports and claims of visitation, that solid, undeniable proof of extraterrestrial life or technology is still missing.
It remains elusive. The question, are we alone, is still wide open. It's one of the biggest drivers of both scientific exploration and, frankly, human imagination.
This was just the beginning. In the next episode, we'll go even deeper. See you there.